Okay, we're live. I apologize if it's really bright, but like the sun is pretty much directly above me, so there's like a solar flare happening on my desk. So I apologize for that. Alright, so I'm going to go through the first third, so it should take me around about 40 minutes. It should be the easier part. Now this is the trial from last year, so I think it'd be kind of interesting to go through it, and yeah, have a go. How many people we got? Xander's here, hey! Better respond. Okay, yeah, so I'm just gonna finish my cookie. Let's go through this. I don't know what the marks were for this last year, but I'm kind of curious. Also, I've got a new camera. You sound like you're underwater. No! Just about to say, I've got a new camera. Let me try something, if I sound terrible. Bear with me. I hope that worked. Microphone, good, yeah. You can. You can't hear me now. What? That's much better. Okay, sweet. Alright. Well, note to self, I won't be using that camera as a microphone. Okay, let's go through this. It's working, sweet. There's 2 people in here and 1 person, Xander. Happy with that. Alright, let's start pretty easy. Here's my function. What's the derivative at 3? I guess an easy mistake would be to just chuck 3 into here, but you know. So I guess I need the derivative first. That's 2x minus 2. Derivative at 3. Notice I'm using the superior notation. No, inferior notation. 3 minus 2 is 6 minus 2, so that's 4. Right. Better get my solutions up so I don't make a mistake, because that's going to be pretty common, I reckon. Hi! Hey Trevor. Okay, what's the natural domain of this thing? Wow. So pretty much what can I put in here that's going to be legal? Anything. I'm not going to break anything by... I guess the only thing you'd look out for in domain is a square root. Or 0. It can't... Oh, actually, if I put a 0 in there, that's going to be 1 on e to the 0, which is 1 on 1, which is 1. So that's perfectly legal as well. So everything. And if you want a picture of what that looks like, that's the same as e to the minus x, which looks like the opposite. So that goes on forever in that x direction, that goes on forever in that x direction, so happy with that. Y primed, no. No, don't use that, please. Alright, uniform, domain, continuous probability. Okay, so I'm going to draw a quick thingo from 0 to 4. If it's uniform, that just means it's a straight line, which means it can't be that, because 4x is a diagonal line. So is that. That's a line like that. It's just whether or not this line is at 4 or a quarter. But keep in mind this area here has to equal 1. So if it was this one, that's 4 times 4, which is 16, so that can't be that. If it's a quarter, then it's a quarter times 4, which is 1, so it's that. Another way of doing it is if that's A and that's B, I think it's, what is it, B minus A on N or something? I can't remember. N being how long that is. I think it's like that. I hate that Y prime's there. Can someone spam the chat with something else? Because it's putting me off. Obviously joking. Okay. Future values tables. So many tables in advanced. How good. $400 every month, every 3 months, into an annuity which earns interest at 4% per annum compounded quarterly. Okay, so first let's go 4% divided by 4, because I've got 4% per annum and I'm doing it quarterly. So that's 1%, sorry. I had that formula wrong. It was 1 on B minus A from before. Just looking at the notes. 1 on, forget that. What was I doing? Alright. After 3 years, so I've got to think about how many times this thing's compounding after 3 years. Do IDX, yeah, see that's better. Okay, after 3 years, if it's going quarterly, then 3 times 4 is 12. So that means 12, 1. I'm looking at this part of the table, so 1268. And because I'm paying $400, this 1268 is for $1. So 12.6825, that's $1. I want it to be $400, so I'll times it. 68. I wonder if there was a way to stream my calculator to the screen. 5073. 5073. Yeah, so before I was using this, my phone, as the webcam and the audio. Maybe I need a microphone. Anyway. Which of the following represents a function whose graph has undergone transformations in the following order? Yeah, right. Okay, so I'm going to write f of x first. Translated left 2 units, so that means x plus 2. That's right, isn't it? Yep. Horizontally dilated. Does this knock out any of these yet? Yeah, it does actually. It knocks out this one. And this one. Horizontally dilated by a factor of 3. Horizontally is the confusing one, because I just want to make sure I'm getting this right. So horizontally is the one where if it's a factor of 3, it's actually a factor of 1 on 3. So, and you've got to factorize. So 1 on 3 outside of x plus 2. So the first thing that affects the x is the plus 2, which was the first thing. So that's why you kind of factorize it. And then what happens? So it's pretty much a, just by looking at it. And then translated down, I can just chuck a minus 4 on the end. So it's this one. They've just written it with that on top, but who cares? That's a, yep. Okay, I think this is a really cool question. These are independent. That's pretty much enough information for the question already, but I just want to kind of give an example. Suppose an independent event might be like rolling a dice and flipping a coin. So pretend this is the probability of getting a 6 on a dice, and then pretend that's the probability of flipping tails, so probability of tails. Then I guess you just got to think about which one's going to give the probability of both of them happening. So if they're independent, you just times them. So this would be 1 on 6 by 1 on 2. If they were, so these two kind of say, if B is so if A has already happened, what's the probability of B? So it could be like, what's the probability that, given I've already flipped a tail, what's the probability I get a 6? So that's what that one's saying. This one's actually saying the opposite. This one's saying that there is some overlap, so the union. So in other words, kind of like asking me about this part. So both of them happening, but that's kind of impossible because I'm looking at 2 different things. They're independent, so I literally just times them together. So it's this one. But that just relies on your knowledge of year 11 probability, which I think is pretty confusing. Okay, first 5 terms of a sequence are, which of the following occurrence relations could generate the sequence? Given this is a multiple choice question, I'd probably just go ahead and try them. So if I start with 5, I'm just going to go through them. Start with 5, I need to double it and add 3. So 5 times 2 is 10, plus 3, yep, that's 13. So 13 times 2 is 26, plus 3, that's 29. Have I got this first go? 29 times 2 is without this. 58 plus 3, 61. Yep. 61 times 2, 122 plus 3. Yeah, okay, so it's this one. Well, that was easy. I feel like that's suspiciously easy. What's this one? 5 plus 13. That doesn't make any sense. 3 times 5 is 15 minus 2. Okay, this one makes sense so far. 3 times 13 is 39. 39 minus 2 is 37. Yeah, okay, so that's not that one. Yeah, I'd just exhaust the options in that case. Which of the following best represents the graph? Okay. Alright, well, these are really confusing. So the first thing I'm going to do is factorize the inside. So I'll take... Oh, geez, what am I going to take out? A1... Oh, I'll have to take a 1 on 2, so I get the x by itself. So then that's x plus... What's a third divided by? 1/3 divided by a half. 2/3? Just so you know, this stuff confused the hell out of me. I just checked that I factorized that right. So a half times this would give me 1. Yeah, okay, that's fine. Yeah, I'm just... Anyway, you want to get the x by itself, like that other question that I had before. And then you can kind of see what's happened to it. So it obviously goes up to 2. That's shown on all of them. This tells me the period. So the period is 2 pi on whatever this value is. So on a half. That's the same as 2 pi times 2, which is 4 pi. That means it does its thing over 4 pi, which is kind of like start and there and this one. So it's one of these two. Can't be these because it does its thing between 1 and pi. So it's not this one. It's not this one. It's just a matter of which one here it is. Cos starts at the top and goes down, so that looks right. It's been moved to the left 2 pi on 3. So 2 pi on 3. If that's 2 pi there. 2 pi on 3 is going to be 1, 2. Okay, so I broke it up into thirds. So it's going to be there. That's where it should start. That one makes sense. I'll just do it with this one. 1, 2, 3. Yeah, okay, that's not the top. So it's A. So cos starts like here. It's been moved 2 pi on 3, which is now this point. Okay. Right. It is A, isn't it? I hate trig. Yeah, okay. Alright. The derivative of this thing. Well, let's use Le Superior notation. D dx of 3 ln 4x minus 2. Let's move the 3 out, because I don't want to deal with that for a sec. Ln 4x minus 2. The derivative of log is the derivative over the original. So the derivative of the inside is 4 over the original. 4x minus 2. 3 times. So that's 12 over 4x. Maybe I'll factorize the bottom. 2 outside of 2x minus 1. Then that and that, so 6. So that's 6 on 2x minus 1. This one. Easy. It's been pretty easy multiple choice. And I've jinxed it. Amount of money is invested in an account that earns an interest rate of R per annum, compounded month. Oh my god. What's R? Okay. Oh, the effective annual rate of interest. Remember this? Oh, it's already told us what it's equal to. So it's equal to this. So, okay. It's told me that it's compounded monthly. You always compare, when you're trying to do effective annual interest, you compare it to a year. If it's compounded monthly, that tells me that the compound interest after 12 months, it's already told me what it is, 1.27%. I'm trying to find R, which is going to be 1 plus R%. That's right. That's right, isn't it? That looks right. Let me just double check. Oh, yeah. Yep. So, because we're looking per annum, you know when you do normal compound interest and you get this, which would normally be 1, you times that by 12, and then you divide this by 12. So I also need to divide the rate by 12. So that by 12. That makes sense. If I didn't do that, you would have ended up with a heaps of whack answer. Probably one that's quite larger. Okay, so now I've got an equation, I just need to solve it. So I need to take, I hate these percentages, 0.1127, 1 plus, I kind of want to write this 0.0r, but that's kind of weird. Okay, I've got to get this 12 by itself. So 1 plus, sorry, I've got to remove the 12. So what am I going to do? I'm going to take the log. I don't want to take the log base 12, that's kind of gross. Oh no, what am I thinking? It's to the power of 12, so I take the 12th root. I had logs in my head then for some reason. Let's leave this exact. So I'm going to add 1, sorry, I'm going to take away 1, and then I'm going to times by 12. So r% is equal to 12 times the 12th root. This is going to be really strange to type into my calculator. 12, the 12th root, I think I've never done that before, 0.1127 minus 1. Ended up with a negative. Why don't I end up with a negative? Do I need to add 1? No. I don't know why I've ended up with a negative. What have they done? Why is it 1.11? Okay, so they said that that's that. I don't like that. I don't know why that's right. That gives me 10.7%. Yeah, so it's this one. Okay. Oh, okay, that makes sense. So it should probably be 1 plus, if that makes sense. So the rate of interest, because this thing's increasing, this would suggest that it's decreased. Whereas I've got 100, maybe I need to write it like this. It's like 100%. Well, I would have got that one wrong. Let me fix that one. Look, I can't get them all right, I guess. Okay. What angle does the line make with the positive x-axis? What a fantastic question. Okay. The angle, so the angle formula is m equals tan theta. I hope you've seen that before. I honestly don't remember teaching that. I hope people have seen that. I hope I taught that. I would have. I just don't remember. Anyway, m is my gradient. What's the gradient of this? I don't know. So let's rearrange it. Let's move. What am I moving? Everything. Minus 4. No, let's just move the 4y. 4y equals x minus 12. Y equals a quarter x minus 3. So that means a quarter equals tan theta. That means theta equals tan inverse a quarter. Tan inverse a quarter, 14, and I'm in degrees, happy. Where's the bubble button on this thing? To the nearest minute. 14 degrees, 2 minutes. Okay, let me think if that makes sense. So I've got my graph. That looks like, so 10, that's minus 3. A quarter is kind of a low thing, so like that. That's suggesting that angle is about 14 degrees. That kind of seems right to me. Have I got a correct answer here? Surely. Yep. Sweet. Okay. A geometric sequence has a first term of that and a common ratio of that. What's the ninth term? Okay. A is my first term, 1/8. Ratio R, 4. Ninth term, Tn equals ARn minus 1. Ninth term would be T9 equals 1/8, 4, 9 minus 1, which is 1/8 times 4 to the power of 8, which is, I don't know why I closed my calculator, surely I'm going to need that again. Divided by 8. 8192. Tell me that's right. Yes. Get excited when I get these questions right. Differentiate that. Okay, well that seems like a product to me. So I'm going to go UV, V U dash plus U V dash, not UV. Okay, that's going to be e to the x. U dash is, oh geez, the derivative of 3x is it log 3x? I'm sure it's that. I need my reference sheet. I'm sure it's that. Let's go with it. 3x ln 3 plus u v dash, which is still that. I've differentiated it. Do I need to simplify it? I suppose I do. I've got an e to the x, 3 to the x in common, outside of a ln 3 plus 1. I don't know where the 2 marks go with that. What did they go? Attempts to use product rule, correct solution. Okay, 1 mark, 2 mark. All right. We're flying. How many questions have we got left? That many. Okay. Actually, what's the time? 22 minutes. No, maybe we're not flying. Find the value of k such that, oh geez. So in other words, perform this and hopefully you end up with a log with 1 number in it. Okay, I've got to differentiate. When you look at a fraction, you want a derivative over original. The derivative of that, okay, so the derivative equals 3x squared. There's no 3 up here. I want there to be a 3. So let's fix it. Let's put a 3 there. And then make sure I fix it. So all I've done is times by 1 essentially. That's equal to, let's leave the third out there. Derivative over original, so that means ln, absolute value, the original, between -5 and -2. What a gross question. Okay, that's equal to 1/3 outside of ln minus 2 cubed, that's going to be -8. Is that right? Yeah, -8. -8 minus 2, minus 10. Minus ln, I hope I'm doing this right, minus 5 cubed. What's that? 5 by 5. It's 125. Should have known that. Minus 125. Minus 125 minus 2. Minus 127. Okay. That means a third. Ln, I'm going to combine these because they've got no thing here, and a minus means a fraction. So minus 10 on minus 127. That means 1/3 ln. Can I simplify that? Nope. 10 on 127. Now I've got to get this third out of the way, so that's going to become a power. So that's a 10 on 127. So the power of a third. So I do the cube root. Oh, I've got a gross number. Have I made a mistake? No, I actually haven't. Wow. Well, that's actually the answer. Therefore, k equals Yeah, right. So I guess all answers aren't nice. I said, hopefully I end up with a single number here. Well, I've ended up with this thing, so... well. Diagram shows a triangle with side lengths. I'm immediately thinking sine rule. Oh, okay, tells me. Sine rule. Alright, I just did a visual check and I was like, do I have this? Yes, I do. Whoops. 2-mark question. Okay, so there's no tricks, I'm guessing. Let's call this... I'm trying to find this, right? A, B, B. I'm trying to find a side, so I'll put A on top. X on sine 102 equals 5 on sine 32. That means X is equal to 5 sine 102 on sine 32, which is approximately equal to 2 decimal places. 9.23. 9.23. Is that right? Yep. Oh my god, almost a flawless run. Oh jeez. Okay. Diagram shows the derivative. Oh, this one's backwards. Remember when we used to draw the derivative given the function? This one's a little bit backwards. I forgot how to integrate sec squared in extension practice test until my genius idea had... Nice. A genius idea. So you let u equal 10x instead of just integrating it. That's pretty funny, actually. I wonder if it had bounds. Did you spend the effort to change the bounds? Because that would have been pretty funny. All right. Whenever you're dealing with something like this, draw them on top of each other. So, well, not on top of each other, but like in a line, if that makes sense. And try and line everything up because it'll make more sense. -3, -1, 2. Okay. I guess I'm just going to do this in pieces. So let's deal with this part first. This tells me, the fact that it's at 0, that tells me the gradient is 0. Oh, what I'm not going to know is where this thing is. So this thing's going to be like, you could have it kind of sitting up here, or you could have it down here, or you could have it crossing. Doesn't really matter, there were no bounds. Yeah, okay. Would have been funny if there were, and you spent the effort to do that. What was I thinking? Okay, so this is the gradient function. This tells me the gradient is 0 at this point, which means it's flat. So let's just put a flat line there. This part tells me that it's decreasing. So the gradient's negative. So I need a negative gradient, which means, hang on, no, don't be fooled. It's above the x-axis. If it's above, that means there's a positive gradient, so it's increasing. Okay, so that means it's coming up. So coming up. Oh, almost made a mistake. Okay, this part is actually. Alright, well, this whole part is below the x-axis. So it's got a negative gradient between there. This tells me that it's got, I need to draw on it. It's got a kind of negative gradient, a really negative gradient, and then a kind of negative gradient. So what the hell does that look like? That tells me point of inflection, I guess. So, oh, this is going to confuse me. Let me start going on this side. That's got a 0 gradient. 0 gradient. Where do I want to draw this? Oh, I'm going to have to go left and right. Okay. Negative gradient. Let's just deal with this. So let's pretend that's -2. It's going downhill to -2. And then it's still going downhill, but it's about to go uphill. So at -1, there's a 0 gradient. So it's like this. So it's going really downhill. And then back to kinda downhill. We're using proper math terms here. So this tells me a point of inflection. Okay, now it's positive, really positive, kinda positive gradient. So positive gradient, really positive gradient, and then kinda positive gradient. Oh, it made straight lines. It's kinda, really, kinda, and then here it stops. So that's zero gradient, and then it's got a really positive gradient. So a really positive gradient. Yum. So that's a point of inflection, including axes and stationary points. That was confusing. You could go back and check, I guess, going backwards, but good. Let's put some arrows on there. Boom. Year 10 trig. Given cos theta is 2 on 7. Let's draw that. Right angle triangle. Cos, let's put the angle here. Cos is adjacent over hypotenuse. Adjacent over hypotenuse. Okay, we're looking in, that's quadrant 270 or 360. That's this one. Oh, sections 2. Okay, so cos is positive. That's, oh, they've told us that. Find the exact value of sine theta. Oh, geez. Let's call that x. X is equal to square root of 7 squared minus 2 squared, which is the square root of 49 minus 4 is 45. Can I write that nicer? Yep, I'll take a 3 root 5. 9 times 5, bring that out. Yep. As far as I can go. Okay. So that means sine theta is equal to opposite over hypotenuse. So 3 on 5 on 7. And sine is negative there. So that means negative 3 root 5 on 7. Okay. Couple more. What are we on? 32 minutes. Not bad, I suppose. There was a hiccup at the start. A set of bivariate data is collected. Graph shows a scatter plot. Calculate the Pearson's correlation coefficient. Damn. Okay. It's only 1 mark. So this is where you'd have to type it into your calculator, but I can't be bothered doing that. 0.89. So if you type that in, got 0.89, that means my line of best fit is kind of close. Like this suggests a strong relationship. I don't know if I call that strong. They're kind of, I don't know. Identify the strength, the strength and direction. Okay, well that tells me it's positive. That tells me it's strong. 1 mark. The equation, give me the equation. Yeah, right. Calculate the predicted length of the earthworm. Oh, the earthworm's 0.7. Oh, so I'm just substituting. So 0.7 is a diameter, that's the diameter. So 0.7 equals 0.045 plus 0.085 times L. I want L, so I need to rearrange. I'm going to divide by 0.045. 0.045. 140.19 equals 0. Why did I divide? I needed to minus. Can't solve a one-step equation. 131 on 200 equals 0. That means L equals. Divide that by 0.085. 131 on 17, which is approximately, rounded to one decimal place, 7.7. If my answer makes sense. 0.7 is here. 7.7 is here. No, here. Do we think the line would cross that point? Potentially. then I'm pretty happy. Last question. The graph, oh, is it? Yep. All right, the graph of y equals sine x is shown. Oh, wow, thank you. I don't have to draw it. Explain why the equation that has 3 solutions. Okay, so this is saying y equals sine x. This is saying y equals 1 minus x on 4. I hate how that's written, so let's write it as negative a quarter x plus 1. Okay, now I can draw that on top and then check that it crosses 3 times. That's what I'm going to do. Minus a quarter. Actually, plus 1. It starts here and then rise over run, goes across 1 and down 4. Oh, jeez. Let's go. How am I going to draw that? Well, let's just find the x-intercept. So that's when y equals 0. 0 equals 1 quarter minus x plus 1. Let's move that over. 1 quarter x equals 1. X has to equal 4. Okay, so it cuts here. That's 2 happy points for me. Hopefully that is a curved line. Oh, that will do, I guess. Let me move this. Why is there a piece on there? Okay, that goes on forever. That goes on forever. How many times did it cross? 1, 2, 3. Yay! Since crosses 3 times. 3 intercepts. I don't know. Sketch it on the graph. Oh, there we go. And I've already done that. Find approximate solutions to the equation. Okay. Maybe I need to get rid of my big things, but whatever. Let's call this 0.9. Wait, solutions. X values, yep. Let's call this 2.8. Let's call this 5.8. Okay. 0.9. Was it 2.8? 2.8. 5.8. Hello, Taylor. Is that it? 2 marks. Let's see what the answers were. Were they close? 0.9, 2.8, 5.8. You're joking. Oh, I surprise myself sometimes. Obviously, I'm joking. Okay, that's it. So, how long did that take? 37 minutes, and I had to get my mic fixed at the very start. Sweet. Alright. Well, I'll continue that. Thanks for joining us, Sander and Trevor. Have a nice afternoon. And yeah, I guess that's it.